Okay, 2013, paper 2, question 1, probability. In the question, you get told that Katie tossed a coin 200 times and threw 109 heads. Joe tossed the same coin 400 times and he got 238 heads. Lucy tossed the same coin 500 times and got 291. So Katie, Joe, and Lucy now think the coin might be biased. So biased means unfair, right? So it might be weighted in favor of one side than the other. So give a reason why they think the coin might be biased. In terms of this, your reason should be mathsy because this is a maths exam. So in terms of Katie, right, Katie is getting 109 heads out of 200, right? So 109 over 200 is not equal to a half. 109 divided by 200 is equal to 0.545, right? Which is roughly 55% of the time she's getting heads. Okay, Joe had 238 out of 400. So again, divided in 238 divided by 400, which gives you 0.595, which is roughly 60%. Right, and if we want to go all three, Lucy, right in here, Lucy is 291 out of 500. Which is roughly 58% of time. So the reason they could think it was biased is when they worked out their calculations, none of them got 50%. Okay, they all got a value bigger than 50%. So Katie got 55, Lucy got 58, Joe, got 60%. So all you simply write down is their values. So you can say 55, 58, and 60 are not equal to 50%, which is what you'd expect for if something was biased. It says Lucy uses all the above data and calculates the best estimate for the probability of throwing a head with the coin is 0.58. Show how Lucy might have calculated this. So what I've shown you in the step before is how to calculate each of their individual goes, right? And what you're meant to discover is the higher up the value, the more accurate the result supposedly gets. So in terms of what Lucy could have done is Lucy could have added all their turns together. So how many times was the coin thrown in total? So we have 500, 400, and 200. So 500, 400, and 200 gives you 1100 throws. And how many times did they get heads? So you would add 109 plus 238 plus 291, and you'd get 638. So what I'm expecting is if I divide 638 by my 1100, I should get, and I do, I get 0.58%. So how Lucy has done it, as I said, is you go total heads over the total throws. Should be H in there. Okay? And then part C, it says Joe agrees with Lucy's estimate of 0.58 as the probability of throwing the head with the coin. He claims that the probability of throwing 3 successive heads is less than the probability of throwing 2 successive tails. Calculate the probability of each event and state whether Joe's claim is true or not. So he is saying that the probability of getting a head is less than the probability of getting 2 consecutive tails. So re are 2 consecutive tails. You could go tail, 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 or tail, tail, head, or head, tail, tail. Right, so there are your three options for getting two consecutive tails in a row. Right, so his probability for getting the heads, we were saying it's 0.78. So for probability of getting three heads in a row, you're going 0.58 times, because it's an and, 0.58 times 0.58. You're saying that is less than the probability of getting three throws. So if your head was 0.58, your tail is 1 take away 0.58. Which gives you about 0.42. So we're saying that's less than 0.42, 0.42, and 0.42, which is our probability of getting three in a row, or which is an and sign, 0.42, 0.42, 0.58, or 0.58, 0.42, and 0.42. So these stand for 0.42 is the probability of getting a tail. So we're going tail, tail, tail. So 0.42, 0.42, 0.42. Tail, tail, head, 0.42, 0.42, 0.58. That's your probability for the head. All right. And head, tail, tail is 0.58, 0.42, 0.42. And as I said, they are or options. So you're getting one or the other. So you're adding their probabilities together. So on the calculator, if you multiply 0.58 by itself 3 times, so 0.58 times 0.58 times 0.58, you get the grand total of 0.1951. Okay, so that's Joe's prediction for the three heads. The tail is 0.42 times 0.42 times 0.42, which is 0.074, or 0.42 times 0.42 times 0.58, which is 0.1023, or your 0.58 by 0.42 by 0.42, which is also 0.1023. So when you add them up, 0.1023 plus 0.1023 plus 0.074, when you add that up, you get 0.27, let me move it again so you can see, 0.2786. So Joe is correct. 0.1951 is smaller than 0.2786. But just in terms of that question, make sure you remember that you've got the three different arrangements. It's not just a matter of you're throwing two tails. If you had thrown the two tails, just gone tail, tail, and not cared about what else was, you would have gone 0.42 by 0.42 and got 0.17. All right. So in that case, if you'd done it that way, you would have said Joe's claim was false. But doing it this way, we're saying Joe's claim is true because 0.1951 is less than 0.2786.